Welcome back. It's your man Jimmy Chan talking about the answer key for LabWork 14B. All right, so the first question is asking if these two lines, and I know that these two are lines because they both have x and y in them, okay? Raised to no power, so that's why I know both of these are lines. So are they parallel, perpendicular, or neither? So what I'm going to do right now is I'm going to go ahead and change into different colors so that I can differentiate them. All right, so the best thing to do is get it to the slope-intercept form, which would be y equals mx plus b, because when I get the y by itself, which is what this is saying, if I get the y by itself, I'll know what the slope is, okay? So let's use the blue equation and get y by itself. So I gotta add the 3x over. So it's gonna be positive 3x plus 2. Then I got to divide everything by negative 6. So y is going to equal to negative 1/2 x minus 1/3. So sometimes when you guys do this, you guys are going to freak out because you see that negative 1/3. But here's the thing. That part doesn't matter. I'm not asking you to graph this. I'm asking about parallel, perpendicular, or neither. So in this case, what I know is that the slope is equal to negative 1/2. Okay, so now let's look at the pink equation. 2x minus y equals 6. Get y by itself, so I got to subtract the 2x over, so negative y is equal to negative 2x plus 6. I got to divide by negative 1, or you can even think about it this way. Just flip every single sign. Because if you flip the sign on the left, you got to flip the sign on the right. Or think of it as if you divide everything by negative 1, same thing's going to happen, right? All right, so my slope here is a 2. So they're definitely not parallel because they're not equal. But the question is, can I take that negative 1/2, flip and negate it, and get a 2? And vice versa. Can I use a 2, flip and negate it, and get negative 1/2? And the answer is, heck yes. So, therefore, these are going to be perpendicular. And that is choice B. There we go. On to number 2. Systems of equations. So this one doesn't ask which way to go. It's up to you if you want to use substitution or elimination. And elimination is also known as the addition method. So with substitution, what you want to do is you want to look at the coefficients and say, hey, is any of these ones have a coefficient of 1 or negative 1? And the answer is yes, right? Essentially, this one right here has a coefficient of 1 or negative 1. With elimination, you just got to decide which one you want to eliminate, and then you want to have the additive inverse as their coefficient. But since that is a negative, you know what? I favor elimination over substitution. So let's go ahead and do that. I'm going to go ahead and duplicate this, and I'm going to show you guys how to do elimination. So duplicate, bring it down, and I'm going to go ahead and do elimination. I'm trying to think of how I want to do this. Let's do this. I'm just going to say using. elimination, okay? So with that being said, I have to choose. So, you know what I'm gonna choose? I'm gonna get rid of the x's, okay? They're both negative, but I need, so the bottom here is a -2. So that means here in this coefficient, I need a +2. In order to make that a +2, I have to multiply that -1 by a -2. So I'm gonna go ahead and multiply this by a -2. If I multiply that by a -2, what do I get? I'm gonna get a 2x minus 16y is equal to 16, right? So if I multiply everything by -2, it will make sense, right? And then the bottom one is as is, is as is, is as is. Oh, there you go. So that's going to be -2x plus 16y equals 2. So now I'm going to, since it's called elimination / addition method, now we get to add them. Positive 2x minus 2x is 0. Ooh, interesting. Negative 16y plus a 16y is also equal to 0. So the left side is going to be 0, and the right side is going to give me 18. Oh no. So the x and y both disappeared on me. So when that happens, you have to look at this statement right here and say if it's true or false. So is 0 ever equal to 18? And the answer is no, it's never equal to 18, right? So it's a false statement. So this is false. And since it's a false statement, that means I have no solution or empty set, and that is going to be choice C. So that only happens if my x and y disappears, okay, and I have a false statement. Now, if this was a true statement, like 0 equals 0 or 18 equals 18, then it's all real numbers, okay? Everything works, all right? Okay, on to number 3, system of equations. Now, this one right here, if you look at it, right? Number 1, look at what it already did. It already solved for y for you, which is great. Thank you. So it's trying to lead me towards substitution. So in that case, let's go ahead and say using substitution, okay? So what I have here is, let me do it this way. Y is being solved for you, which is equal to -3x. So I'm going to replace the y above that with the -3x. So I'm going to have x plus a -3x is equal to 4, which we all know that this means x minus 3x is equal to 4. So I have -2x equal to 4, because 1 minus 3 is -2. Divide both sides by -2, so my x is going to equal to -2. Okay? So with that being said, this tells me that yes, I have two lines. They're going to intersect in one place. The x value is -2, so that means I got to find my y value. So I'm just going to take that second equation, y equals -3x, and solve for y, and just replace that x with that -2. So my y is going to equal to +6. So with that, those two things right there, it tells me my point that these two lines are going to intersect at is going to be -2, 6. And that's going to be choice D. There we go. All right, on to number 4. Factoring. Ooh, this is 4 terms, right? If it's 4 terms, we do factor by grouping. So let me do this here. Let me move this first step down. And so factoring 4 terms is called factor by grouping. Right? So first thing we do is split the first 2 terms and the last 2 terms. So you guys remember this. Work. Just gotta make it straight, right? So what was second step? The second step was to factor each group separately, right? So I gotta factor the first group. So I'm just looking at just this part here and saying, what's my GCF there, right? My GCF there is an x squared. And what do I have left if I take out an x squared? I have an x plus 9, okay? All right, so now I'm looking at a second group over here. When I have nothing to factor out, I'm gonna factor out 1. And what would I have left is just x plus 9, okay? All right, with that being said, third step is factor as a whole, okay? So when I look at this, what do they have in common? They have the x plus 9 in common. What's left if I pull out x plus 9? The x squared plus 1, okay? And that, ladies and gentlemen, is going to be choice A. There we go. All right, on to number 5. So I gotta graph this, and this is an inequality. Okay, so in inequality, one of the things we talk about is the symbol here, right? So this symbol tells me what? Tells me that this is going to be a solid line, right? Because if it's less than or equal to or greater than or equal to, as long as there's that equal sign, that means that it's going to be a solid line. If it's just a less than or a greater than without that equal sign, then it's going to be a dotted line. So I'm going to look at this equation as if it's a regular equation, so I can get my line here. I don't know why they put down plus -1, but it's the same thing as saying -1. So my y-intercept is 0, -1, and my slope is 3/1. So that means I gotta go up 3 and right 1. All right, so 0, -1 is right there. I gotta go up 3 and right 1, so I'm gonna be right there. Okay, and this is going to be a solid line, which is great. So I'm going to draw a solid line, and I'll make this right in just a moment. Boom, right there. All right, so I got my arrows there and there. So now with inequalities, there is multiple solutions, meaning which way do I shade, right? So I have to test a point. Now the point that you test can be here on this side or a point on this side, okay? Basically you're asking those points, am I on your side or am I on the other side, right? So let's say I test, you know what, I'm gonna pick the right side, something like, let me see, 2, 4, 5, 2, 4, 5. So I'm gonna test this point right here. This point here is 5, 5, okay? It's clearly on the right side. So I'm gonna go ahead and test a point, and that point is gonna be a 5, 5. All right, so I'm going to plug it back into the original equation. So the question is, y is that, oh, sorry, 5 is that less than or equal to 3 times 5 minus 1. Okay, so let's take a look. Is 5 less than or equal to 15 minus 1? Yes. Right? So it is. So that means I'm on the same team as 5, 5. So that means I will be shading on this side. Which means if I was to test a point on this side, this would give me a no. If I did this point, no. This point, no. This point, no. But if I picked anything on this side, it'd be yes. Yes. Okay? So that is the case. And this, ladies and gentlemen, is going to be choice B. There we go. All right, on to number 6. Ooh, system of inequalities. Okay, so same thing. This one right here tells me that it is going to be a dotted line. And this one right here is going to tell me it's a solid line. Okay? Awesome. So let's go ahead and deal with the red line here. And the red line says x plus 2y equals negative 4. I'm going to get y by itself, so I got to subtract that x over. So I'm going to have 2y is equal to negative x minus 4. Divide everything by 2, so y is equal to negative 1/2 x minus 2. Because negative 4 divided by 2 is negative 2. All right, so my y-intercept is negative 0, negative 2. And I got to go down 1, right 2. Okay? So, with that being said, I'm just going to keep on going down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And I'm going to go the other way the same way. I'm just going to follow that same pattern all the way through. Okay, so here's my attempt on the dotted line. There we go. All right. And then I'm going to go ahead and do the second one, which is y is equal to negative 2. Well, so the red equation had both x and y in it. So that's why I know it's going to be a diagonal line with a slope. However, if there's only an x or only a y in there, then that means it's either a vertical line or a horizontal line. The question is, how do I know which one is which? So the y equals negative 2 just tells me this, that the y value is always equal to negative 2. So if I do a point here and a point here, let's just put 2 points, the y value is always negative 2. I can make up any other x's. So let's say, I don't know, negative 5 and 5. So let's go ahead and plot those 2 points. All right, so negative 5, negative 2. 2, 4, 5, negative 2. So that's negative 5, negative 2, and 5, negative 2. And if I connect those two lines, those two dots, and create a line, it's going to be a horizontal line. And what I know here is that if it's going to be less than, it's going to be everything below. Okay? Everybody see that? Now, with the red one, I need to test. So 0, 0 is available. So for here, I'm going to go ahead and test. Here, let me do this here. There's some space there, so let me do this. Okay, so here I'm going to go ahead and test 0, 0. Okay, so if I test 0, 0 in the original equation, that tells me that 0 plus 2 times 0 is that greater than negative 4. So is 0 greater than negative 4? And the answer is yes, it is. So that means this is going to go towards 0, 0. So it's going to go something like this. So if you notice, where is it double crossed? Well, it's double crossed. Actually, I probably shouldn't have used purple, even though if I tested that, I should use this. So if you notice where it's double crossed, is actually right in here, right? So that means the rest of this is really kind of useless. Okay, so that is where my solution is, and that's going to match the graph that is choice D. There we go. All right, on to the number 7. All right, it wants me to solve. All right, so I see a power that is greater than 2, or greater than 1, I should say, and an equal sign. So that should automatically make me think of quadratic equations. So that means I gotta get everything to one side. All right, so let's go ahead and get everything to one side. So I got 5x to the third minus 4x squared minus, oh boy, those are not x's. Those are very much z's. Okay, I'm just gonna erase them. Let's rewrite. 5z to the third minus 4z squared minus 9z is equal to 0. Okay, so I got to factor my non-zero side, which is the left side, and I have a GCF of a z, which leaves me with a 5z squared minus 4z minus 9 is equal to 0. All right, so with this being said, then let's go ahead and since I got to factor that left side anyways, step 2, factor non-zero side. Okay, so let's go ahead and do the AC method here. Okay, so when I look at the AC method, I'm only looking at this right here. All right, so this tells me my A is equal to 5, so that this way I actually refresh on the AC method. B is equal to negative 4, and C is equal to negative 9. So AC method, so I got A times C is going to equal to negative 45. My B is equal to negative 4. So here I have to find my two numbers that multiply together is going to give me that negative 45, but yet added together would give me that negative 4. So I'm going to purposely choose this 5 and negative 9, right? If I multiply those two, it will give me negative 45. If I add those two, it will give me that negative 4. So after that, I have to split the middle term. So I still have the z on the outside, but the inside is going to be 5z squared. And we'll replace this negative 4z with these two numbers here, right? So it's going to be plus 5z minus 9z minus 9 equals 0. Okay, now I have 4 terms, so I'm going to split it down the middle. I'm going to factor the first part first, and that is going to give me a 5z as my GCF, leaving me with a z plus 1. And remember this, guys, if the third term is a negative, I'm going to pull a negative. Negative what? A negative 9. And what does that leave me? It's going to be a z plus 1 as well. Okay. with that z on the outside. So I'm going to have z. And then what's in common inside the square bracket is the z plus 1. What do I have left is the 5z minus 9 is equal to 0. Okay, so what's the third step? The third step is to set each factor equal to 0 and solve. Okay, so let's go ahead and do that. So now I have z equals 0. I have z plus 1 equal to 0. And I have 5z minus 9 equal to 0. Okay, so I got the z equals 0. This is going to be z equals negative 1. And this is going to be 5z equals 9. And then divide the 5 so that z is equal to 9/5. So my answer is that z is going to equal to negative 1, 0, and 9/5. And ladies and gentlemen, that is going to be choice D. There we go. Close enough. All right, so that's number 7. On to number 8. All right, so substitution or elimination. Well, again, same thing. The y is already solved for me, so that automatically tells me I should go ahead and do substitution. Okay, so with that being said, I'm going to go ahead and erase the elimination part, and we'll move the substitution over, and I'm going to say using substitution. Okay, so same thing. I'm going to replace the y in the second equation with the y in the first equation. So I'm going to have x minus 6 times 1/6 x plus 3 is equal to negative 18. And of course you guys always freak out because you see a fraction. So I got to distribute the negative 6 through. So I'm going to have x. Now negative times positive is going to be negative. 6 times 1/6 is actually going to equal to 1x. And then negative 6 times 3 is negative 18 is equal to negative 18. All right. Ooh, look at this. So combine like terms, x minus x is going to be 0. And then I'm going to add the 18 over, and that's going to give me 0. So x and y disappeared, or the x disappeared. The y has already disappeared. The x disappeared, right? Since the x disappeared, so when that is the case, I have to look at this statement right here. What does this state? Is this statement true or false? Is 0 always equal to 0? And the answer is yes. So this is a true statement. So that means it's going to be all real numbers. Okay, but mathematically speaking, the way they put it is that for all x and y, such that y is equal to 1/6 x plus 3. All right, so they're saying that any x and y that you use, it's going to work for this equation, and that is choice B. There you go. Okay, on to number 9. Factoring two terms. So the first thing I got to do is ask myself the question, is it the difference of two squares? Well, before I even do that, I got to do GCF first, right? So in this case, I do have a GCF, and it's going to be a 3x. If I pull out 3x, I'm going to have y squared minus 16. Now I should ask myself the question, is it the difference of two squares? Y squared minus 16 is the difference of two squares because y times y gives you y squared. 4 times 4 gives you 16. So I'm going to have that 3x. And then this y squared minus 16 is going to be y minus 4 and y plus 4. So that is going to be choice A. And there we go. All right, on to number 10. Oh, your favorite. Your favorite. Okay, so one of the things I always talk about with these type of word problems when it's describing one leg and comparing it to the smaller leg, comma or period. So in the first sentence it says one leg is 21 inches longer than the smaller leg, comma. Okay, so this comma means something. It means that whatever is describing before that comma is going to be my x. Okay, so this is my smaller leg. I'm going to call it x. So this is my smaller. And I'm going to call this my longer. And I have to call those two smaller longer because this is my hypotenuse. Right? And it says, so my smaller leg is that. So my longer leg is 21 inches longer than x. So this is going to be x plus 21. Okay? So notice what I just said to you guys. One leg is 21 inches longer than x. Like I literally replaced smaller leg with just x. So when I speak it, I can just reread it exactly that way. 21 inches longer than x. Okay? So if I look at the next sentence, look at this. Same thing, right? So it says smaller leg right here. So we're going to replace that with, with x again. So I can say the hypotenuse is 24 inches longer than x. So 24 inches longer than x, so it's x plus 24. Okay? All right, so it says find the length of each of the sides. Well, I know a formula that talks about all three sides of a right triangle, which is going to be the Pythagorean theorem, which states a squared plus b squared is equal to c squared. Okay, so I have x squared plus x plus 21 squared is equal to x plus 24 squared. Okay, the hypotenuse is always by itself. So I should actually line up that equal sign here. Let's do that. There we go. All right, so this is actually saying x squared plus x plus 21 times x plus 21 is equal to x plus 24 times x plus 24. Correct. Because of the square, I got to write it twice, and that means I have to either FOIL or double distribute both of these. Okay. All right, so I got x squared plus x squared plus 21x plus 21x plus what's 21 times 21? I believe that is going to be 441. Is equal to x squared plus 24x plus 24x plus 576. Okay. Woo, let's combine some like terms here. So do this. So that's going to give me a 2x squared. That's going to give me a plus 42x plus 441 is equal to x squared plus 48x plus 576. Okay? But look at this, guys. What do I see? I see x squares and an equal sign, which tells me That's right, quadratic equations. Man, you guys are so smart. All right, so that means I gotta get everything on one side. So what I'm gonna do is I'm gonna go ahead and subtract this x squared. I'm going to have to subtract this 48x. And I'm going to have to subtract this 576. Okay, what do I have? Seems like such a long problem here, right? Okay, so I'm going to have an x squared minus 6x minus 135 is equal to 0. So you can go ahead and use the AC method here. So you may even have to make a table. 135. Think. So this is going to be x minus 15 and x plus 9. 9. Okay, so that means x is going to equal to 15 and x is going to equal to negative 9. Now, since I'm talking about sides of a triangle, I'm going to have to reject the negative because I can't describe a side of a negative. Yes, you're right. X is going to equal to 15. However, I'm not done answering the question. The question was find all three sides, right? So what did I have? I had the smaller equal to x, so that's equal to 15. The longer was equal to x plus 21, so that would be 15 plus 21, which is equal to 36. And the hypotenuse is equal to x plus 24, so that's going to be 15 plus 24, which is going to equal to 39. So I have 15, 36, 39 as my three sides. So that is going to be choice C. And there we go. All right. All right, and that is number 10. All right, so this is the answer key for 14B. If you have any questions, please let me know. Talk to you later. See ya. Bye.